Good morning, my dear students. Welcome to the next class. My name is S, and I'm your physics teacher. As I have already introduced myself to you last time. In today's class, I'm going to teach you three topics. The first topic is universal law of gravitation, and then we'll try to write the unit and dimensional formula of universal gravitational constant Z, and then we'll go ahead and find out the relation that shows Newton's law of gravitation in the vector form, or in a simple language, we'll try to write Newton's law of gravitation in the vector form. So let's get ready. Let me just transfer the camera. Just hang on. Let's go to the table where I put my paper and pen. Okay, just hold on again. It will take us a few seconds. Here we go. Let me just zoom the camera. Okay. So right now you can see I'm selecting three topics here. The first one I'm going to find this universal law of gravitation. In other words, I'll be just explaining what it's all about, this Newton's law of gravitation. Okay, so let us do the first one. When you talk about this universal law of gravitation, usually we need to consider two mass here. Now we can say I'm just considering two mass. It may be 1 kg, it may be 1 kg like that. Then, just for notation, let us just write as M1, this is M2, and you make them separated by a distance of r here. Remember, the separation must be made between one center to the other center, only center to center only, okay? Then, the universal law of gravitation says that there should be an attractive force, F should be attractive, okay? It should be attractive, and this force will be directly proportional to the product of the masses. It means M1, M2 should be there. I already told you last time to memorize that formula. I'm coming to that formula again. And again, the force of attraction also varies inversely with the square of the distance here. You need to write square here. Okay? So, if you combine these two, what do we have? We have this F directly proportional to M1, M2 divided by R square. So, the explanation goes like this. This force of attraction will become very strong if you increase the masses. Suppose you increase the mass. Instead of 1 kg, make it 5 like that. Then obviously the attractive force will be stronger. Okay. On the other hand, if you increase R means you keep the two mass very far. For example, say you increase the distance. So at that time, R is increasing. That's why F should be decreasing. All right. So we have to know that in the case of relation, if A varies directly with B, then A must be equal to a constant KB here, where K is known as a constant here. There should be always a constant to verify the relation, just like that. So we're going to have another constant here, F is equal to Z M1 M2 divided by R square. Okay, so this is what we call as the universal law of gravitation. All right, and this Z, this is a constant. This is a constant known as universal gravitational constant. This is known as universal gravitational. Sorry, microphone fell down. Okay. So for the notes, I just wanted to go through the textbook, and you can find it out there. So in other words, the force of attraction between two bodies is directly proportional to the product of the masses, and is inversely proportional to square of the distance here. This is the statement of Newton's law of gravitation. Then we'll go ahead and find out the second point here. This is the unit and dimensional formula of Z. Let us see how to find the unit. Here you can see unit and dimensional formula of Z. Let's see how to find it out. We're going to find unit and dimension here. Okay. This should be dimensional formula. All right. Of Z. Let us see. First, you select the formula. This is what F is equal to Z m1 m2 by r square. Okay. Do cross multiplication. You get Z m1 m2 is equal to what? F r square. Right. Then Z is equal to what? F r square divided by m1. Next come m2 here. Then in terms of unit, let us see. Usually we'll be talking about the SI unit. Okay. In SI unit, we also known as what? MKS. MKS means what? Meter, kilogram, second. Okay. In meter, kilogram, second, in SI unit here, F for force. Force will be Newton. Okay. Newton is the SI unit of force. Don't forget it. Newton is the SI unit of force. Like that, distance is what? Distance is r. So this will be measured in terms of meter. Meter for small letter m here. Okay. And the mass is here. Mass for m here. This would be kilogram. Kilogram means what? This will be kg. Okay. So you put all these values here. So you get force for what? You have this Newton, r for meter. There is square, just put on square here, right? Then mass. You have two mass. So kg for one mass and kg for the next mass. So you have kg for m1 and 2. So finally you have n m square and 1 kg square, which is equal to Newton meter square per kg square. This is what? The SI unit of what? Z. Okay. So this is the SI unit of Z. So now you have learned how to write the SI unit of Z. Then we'll go ahead and find the dimensional formula. Okay. So to find the dimensional formula, bring back this again. This one. G is equal to, let me write the formula one more time, force r square divided by m1 m2. Okay. So in terms of dimensional formula, as we know, force is the product of mass into acceleration, right? As we know, force is the product of mass and acceleration. So we can write mass into acceleration means what? Velocity by time. Okay. Which is equal to mass into velocity means what? Displacement by time. Whole divided by this time. You bring it back again. I repeat again. Velocity is equal to displacement by time. You have learned in class 9. Okay. So which is equal to mass. Let me write again. Mass into, this one is displacement by this time will multiply, will become what? Time square. Okay. Let me check the time. So it's equal to mass. In terms of mass, I mean dimensionally, in terms of dimension, how can you write this mass? Usually, let me just show you. Actually, this should be done, okay, in the chapter 2. I'm just skipping that. Here, remember, there are three basic quantities we need to take here. M, L, T. Okay. M for notation is what? Mass. L for length, and T for time. Okay. You have to bring it these three quantities. Not only three, there are some more quantities. It need to be shown in different classes. So write this. Mass I write as M. Okay. Displacement, as I just said right now, amount 3 here, mlt here. L is similar to displacement, okay? So instead of the displacement, I'm going to write what? L here. So I can write, instead of displacement, I can write L here, okay? Time is what? T square. So you have this mlt minus 2. This is the dimensional formula of what? Force. This is the dimensional formula of force. So dimensionally, force can be written as mlt minus 2. Okay, don't forget it. So now let's bring back here. So F is here, so I can write mlt minus 2 is there. Next is here, you can see r for length or distance. So just now I've shown that length can be written as what? L here, L, okay? So instead of this r square, I'm going to write L square here, right? Divided by mass, you can see here, m1, m2 both are mass. So mass is denoted by m here, so let me write double m here, m square here, okay? Just factorize this. So you have this m will cancel. So you're going to have L3 t minus 2. Down here you have only m here, okay? Because m will cancel. L cubed t minus 2. Then you can write m. You bring it up here. M minus 1, L cubed and what? T minus 2. Okay. So this must be the dimensional formula of universal gravitational constant. Let's go through it one more time. Let me just verify it whether what we have solved is correct or not. Yes, it's correct. M minus 1, L cubed T minus 2 is correct. Okay, this is the dimensional formula of universal gravitational constant. Okay, so you need to practice this. Then comes Newton's law of gravitation in the vector form. Let us see how to write Newton's law of gravitation in the vector form. Okay, so let me select a new page here. Now, let us see. Here is the first mass, this is the second mass here. So let me write m1, this is m2, okay? Join from center to center. Let us say distance is r as before. Then, if you look here, if you look at the two masses, what do you find? They are kept at a certain distance, as we know. Then, the force, that is what the force acting between the two masses, we have to find out again. So let's just think that this m2 is for pulling this m1 in this direction, okay? Like this m2 is pulling m1 in this direction. So let the force be F1 to 2. F1 to 2 means that it simply means that the force goes from what? This 1 to 2 here, okay? So like this, if m1 is pulling m2 in this direction, let the force be F21 here. Okay, keep in mind what I'm doing there. Then we need to see the distance also. So in terms of distance here, just for the force F1, F12 I mean here, let the distance be taken as R12 here. And for the second mass here, M2 and F21, let us think that the distance be taken as what? R21 here, R221. The first one is R122, the second one is what? R221 here, okay? So what I meant to say is that F12 is the force, F12 is the force here acting on M1 by M2. In other words, just think like this in simple language, okay? Don't confuse too much here. This is separation is R here. Then for the mass M1, for the mass M1, let the force be F12, okay? And let the distance be what? R12. At the same time, for mass M2, let the force of attraction between them be F21 and the distance be what? R21. That's all, okay? Just remember in this way. It's the easiest way to remember. Otherwise, you may be in trouble here, because this may be a bit advanced for you, okay? I know it is a bit advanced for you because you have not learned vector quantity and you have not learned that the scalar quantity, vector quantity, and how to write in the vector quantity. I know you have not learned it. That's why it might be a bit confusing, but just for today, just give it a try, okay? See whether you can understand or not. All right. So, let us see. So if I'm going to select here the force here, F12, this will be equal to, if you follow the formula, F is equal to a Z M1 M2 by R square. Following this one, you can write F12 the same way here. Z will not change because the Z is a constant. Oh, sorry, okay. Oh, I thought you cannot see it. Okay, G is a constant here. Then choose the mass M1 here. You can write M1, M2 here. Okay, and as I just said right now, for the force F12, the distance is what? Here, what is the distance here? R12. But here, the actual distance between the two is what taken as here? R here. So keep on writing here R square. Okay, and you need to select the unit vector. This one is known as what? Unit vector. This is known as what? Unit vector. Okay, so this unit vector, select the unit vector corresponding to F12 here. This is nothing but R12 here. Okay, similarly F21, for the second one, F21, the force is F21 here. Go ahead to the other side, write Z as before, because Z is a constant, will not change. Select the two masses, you have M1, M2 divided by, again the separation is what? Again here, R square. Okay, then you select the unit vector related to F21. So related to F21 is nothing but what? R21 here. Okay, so in other words, write like this here, F12 is equal to Z. This will be in the vector form right now. So put the vector over, I mean the arrow, put the arrow here. Z M1 M2 by R square. Then what? R12 unit vector. So this must be the low gravitation in the vector form. Or you can write like this here. F21 is equal to Z M1 M2 by R square. Then what? F21 is R21 cap here, or unit vector. Okay, so these two equations represent the law of gravitation in the vector form. And I know it might be a bit confusing for you, and it is quite natural because you are learning this vector just for the first time. That's why you may be having some trouble. Okay, I just want to show my face to you all again because I wanted to say something. Alright, I'm just removing the camera. Okay, it's too much. Okay, so what I want you to do during your free time is that you go through these notes one more time by yourself and go through each of the steps properly. Okay, step by step, whatever I have told you just now, and check whether you can follow the steps or not. If you have some difficulty following the steps, don't hesitate. You can contact me by WhatsApp and I can make some clarification regarding that. So for today I'll be ending up the class, and I know it is quite sometimes, no, it might be a bit difficult for you, but just you have to accept that. And as I said, if you have some difficulty, just keep on posting some question or some comment to my WhatsApp number, then I'll be happy to help you out. Okay, so just for today, let's stop the class and see you in the next class again.